that we are testing by substitution. All right, solving power equations. So when we're solving power equations, what we're really talking about is having exponents here. So power equations are equations of the form x to the n equals a, and that can be solved by taking a radical, whether it's the square root, the cube root, the nth root, the whatever root, okay? So the power equation x to the n, where a is equal to 0, has the solution x is equal to the nth root of a, and that's if n is odd. So we don't have to worry about plus minus if our radical is odd or our power. But when it's even, we do have to worry about that plus minus. That could give us either answer. Think about it. When I raise something to an even power, it's automatically a positive solution. So that's why we need to account for the fact that x could have been positive to start or x could have been negative to start. It's also important that whatever goes under the radical is got to be positive when we're taking an even root, because we cannot take an even root of a negative and get a real solution. We're going to talk about in 1-4 what happens when we do take the radical, the even radical of a negative. All right, so if n is even and a is less than 0, like I just said, there are no real solutions. So let's take a look real quick. We have this fifth power, x to the fifth power. So to solve this, what I'm going to do is find the fifth root of both sides, right? Fifth power and fifth root are inverse operations. So I'm left with just x, and that's going to equal, I have to say to myself, what to the fifth power is going to be 32? You might not know this, so we could factor tree if you're not sure. That would be 4 times 8. That gives me 2, 2. 8 gives me 2 and 4, 2 and 2. And I notice there are 5 number 2s. So that means x has got to be 2. Okay, because it's odd, I'm not worried about plus minus. If I did negative 2 to the fifth power, I would get negative 32. So I don't have to worry about that. All right, the next one. The fourth root I have to take to undo that fourth power. So again, 16 you might not know. That would be 4 and 4, so 2 and 2. 2 and 2. So there are 4 number 2s. So we know that the fourth root of 16 is going to give us 2. But because this was a positive exponent, we need to account for that plus minus. 2 to the fourth power is 16, but negative 2 to the fourth power is also positive 16. All right, let's take a look at the next one. So we have negative 32 if I do the fifth root of both sides. In order to get negative 32, that means 2 must have been negative. So we have x is equal to negative 2. That works, no problem. Think about it. If I write it out, negative 2 times negative 2 times negative 2 times negative 2 times negative 2, 1, 2, 3, 4, 5 negative signs gives me a negative solution. All right, the fourth root on both sides, I cannot take an even radical of a negative, so there is no real solutions here. There is no real solution here. We'll talk about when we get to section 1-4 what does happen though. All right, next example. So in order to solve these, what we want to do is get the power by itself, and then we can use our radical. So we'll add 5 to both sides. So we're going to get that x squared is equal to 5, and then I can take the square root of both sides, but because it is an even root, square root, we get plus or minus whatever the square root of 5 is. We cannot simplify that, so if we want an exact answer, radical 5 is just fine. In number 6, there's nothing outside of my square. Everything's inside, so I'm going to square root to get rid of that little 2. That really gives me 2 solutions, though. I get x minus 4 is equal to positive or negative radical 5, so I really need to solve this equation twice. I can have x minus 4 is equal to positive radical 5, or I could have x minus 4 is equal to negative radical 5. I'll add 4 to both sides, and it's just an ugly expression. I'll get that x is equal to, that's positive 4 plus root 5. And then when I add 4 here, x is going to equal positive 4 minus root 5. So both of these could be solutions. I should always go back and double check, but both of these will be solutions. All right, number 7, cube root. So to undo the cubed power, the third power, to undo that, we are going to use the cube root. I can cube root a negative because that is an odd. So I am allowed to do odd of negative. That's totally fine. That's going to give me a negative solution. Totally fine. All right, so 8. The cube root of 8 is 2 because x is to an odd. We're going to deal with that negative, so we're going to get -2. And just double check, -2 times -2 times -2 is in fact going to give us that -8. We're in good shape. All right, the next one, I should divide by 16 first to get rid of that. So if I do that, I'm going to get x to the 4th is equal to, let's see, 81 over 16. I don't believe that's going to simplify for us. But I can do now the 4th root of both sides. All right, so what we can really do here is say I have x is going to be equal to plus or minus, and I'm going to really take the 4th root of the numerator and then the 4th root of the denominator. I can treat those separately. So 81, we have 9 times 9, and that's 3 times 3. Kind of a nice trick with the 4th root is just take the square root twice. So the square root of 81 is 9, right? The 4th root of something is really equal to the square root of the square root. That would give me 3, which is kind of convenient. So square root is 9, square root again is going to give me 3. I can do the same thing with 16, or I can write it out, or we did 16 before, and we're going to get 2. So don't forget we've got plus or minus 2 there. All right, number 9. Same kind of concept here. It's just going to be a little bit uglier. We're going to add 2 to both sides first. So I have 5x to the 2/3 is equal to 45. We'll divide by 5. We want to make sure that power is all by itself. So x to the 2/3 is going to equal, 45 divided by 5 is 9. All right, so the next thing that I want to do is make sure that that 2/3 is going to disappear. So I could do this a few ways. For me, I think the fraction's not so bad to deal with. I want to really make that an x to the 1st power. So how can I do that? I can multiply by the reciprocal for that exponent, which is kind of a neat little trick here. Or I could have said x to the 2/3 really means x squared, and then the cube root of that. And then I could have either cubed both sides and then square rooted, or the other way around. It doesn't matter, but to me, this is just a little bit quicker. All right, so x is going to equal, and let's see, for that 9, we are going to have, let's see, that's the square root technically of 9 cubed, right? So the square root of 9 cubed. Now don't forget, because we're undoing this, what's really happening is we're square rooting and cubing. When we're square rooting and cubing, that should give us that plus or minus here. All right, so x is going to equal plus or minus. The square root of 9 is 3, so 3 cubed. 3 times 3 times 3, I believe, is going to give us 27. So x is going to equal plus or minus 27. Again, we could put that back in for x and double check that that works. But when we are squaring it, that's why we're allowed to have that plus or minus going on. All right, number 10. So we have to solve for m. So m here is just a variable. I want to make sure I'm just undoing everything. What might be convenient first is to make sure I see that g is really a part of the numerator when I'm multiplying. That might make my life a little bit easier. So if I think of this as f is equal to, and I think this is the force formula, but I'm not really sure. One's a smaller mass, one's a larger mass. G, I think, is maybe gravity. It's been a while since I've done physics here. But if I think of g as being part of the numerator, it's going to make my life a little bit easier. So we want to start moving things away from the m. The first thing I'm going to do is multiply by r squared on both sides. So I get f r is the only thing squared, is equal to g m. We want to solve for capital M. So I'm going to divide by g and lowercase m. So that's going to give us that capital M is equal to f r squared over g lowercase m. And it's really just a matter of rearranging. When you were in Algebra 1, they likely called these literal equations.